Hello, today we'll discuss on Reimann Sum. So, what is Reimann Sum? Reimann Sum is an approximation of an integral by finite sum. That's why for the formula of actually in Reimann Sum is useful for getting the definite integral, where the equation is like limit n to infinity is same with epsilon n I equals to 1 and fx times with delta x, where the fx is the height of the rectangle while the delta x is the width of the rectangle. So why we have an infinity here? We have the infinity so we can make the rectangle to the number that we cannot calculate, so the accuracy of the area under the graph, it will be higher. So as an example, here we take the question x squared from 4 to 0. So we already have a question, but to answer this we need some ways, so we need some steps on answering it. So in first step we'll try to find our delta x, second step we'll try to get our xi, third step we must substitute the xi into the function, then fourth step we will find the summation, and finally we'll use some sum laws. So let's start with the first step where we will get our delta x. So the formula for delta x is b minus a over n. In this case the b is equal to 4 while the a is equal to 0. So if we substitute that, we will get 4 minus 0 over n, where the delta x is equal to 4 over n. Then the second step, the xi. The formula for the xi is a plus I delta x. In this case the a is equal to 0, and then we will plus with I, and the delta x was the previous answer that we got, which is at 4 over n. So from here we will get 4 over ni, which is the xi. Then the third step, we should, okay, now our function is x squared, so we have to substitute our xi in the function, where we will get 4 over ni squared. Then if we expand this, we will get 16, which is a 4 square will become 16 over n square and I square. Then we will move on to the Reimann sum, epsilon n and I is equal to 1. So here we will use the formula of fx delta x. Then we'll get our fxi was the 16 over n square I square, while our delta x was 4 over n. Then if we solve this equation, we'll get 64 over n cubed I square. Then we have to move on the epsilon for the, we must make the I square as the subject for the epsilon, so we move the 64 over n cube in front, so epsilon and I square, so it become like this. Then we'll move on, we'll use the sum laws, where in the sum law I is equal to n plus 1 over 2 I square is equal to n plus 1, 2n plus 1 over 6, while I cube is equal to n plus 1 over 2, and the whole equation is squared. So in this case it's I square, right? So we will just substitute the value of I square here to the what equation. Yep. So if we substitute that, we will get 64 over n cubed times with n plus 1 to n plus 1 over 6. And then if we solve this, we will get 2n cubed plus 3n squared plus n over 6. So to make the equation easier, we'll remove all the n parts inside this equation, and then we remove the number part in this equation. So here we'll get 64 over 6, and here we will get 2n cubed over n cubed plus 3n squared over n cubed and n over n cubed. So this number here we can simplify as 32 over 3. Then here we should use our definite integral, where the limit of n approaching infinity. So we can cut down the numbers here, so we'll get 2 plus here we will get 3 over n, and here we will get 1 over n square. So if we solve this, we'll get 32 over 3 times by 2. All of this 3 over n and 1 over n square will become 0. So our final answer will be 64 over 3. Tada! This is the answer. And thank you. See you next time.